name is Marwan Abdelgawad. I was mainly responsible for the accelerometer part of the project or of the course, along with connecting the code with each other. So mainly my part was programming or taking input from the accelerometer. The one that we used was ADXL345. Uh, the method that I used, or the thing that we used in our project, was the I2C, which means that we connect the Arduino with the ADXL245 in order so that make it easier to communicate. We use that throughout two things: the Adafruit library, which helps us communicate with the ADXL245 much easier, in which we took inputs from the accelerometer throughout three axes, X, Y, and Z, in order to know in which direction or the detection of the directions, in order to control the car along with it with the hand gestures. So mainly we use the 4 pins from the accelerometer, the SDA, the SCL, and 5 volt and the ground. The 5 volt and the ground are connected to the 5 volt and the ground from the Arduino in order to have a common ground between all the ports. Regarding the SDA and the SCL, they were connected to the pins on the Arduino, the one with the pins 13 and 14, in which they have the I2C, where it was mainly responsible to get the SDA or the data from the connection and the SCL. It was given to the Arduino and then converted into the output that we needed in order to use the one of the X, Y, and Z axes. Regarding the code, we used a library called the Adafruit. This library, or actually two libraries, which actually helped us a lot: the wire library, and the Adafruit sensor, and the Adafruit library, the Adafruit 345 ADXL. Those two libraries helped us in order to communicate it much easier, or to use the I2C in the optimum way. And the Adafruit helped us to connect, or to make the whole system connect to the same clock and the same measurements actually. After that, it took the input from the ADXL and converted into the 3 axes as mentioned. So it actually helped us, and the connections of the SCL and SDA were from the ADXL 345 to the last pins on the left of the Arduino from the digital port, so that it can help the I2C, as Arduino supports the I2C method, make it easier to communicate with the ADXL 345.
Hi, I'm Ahmed Ayman. I worked on the ultrasonic sensor. The ultrasonic sensor is used to tackle any object from a distance. If it finds any object, the car or the object it's used on will move far away from that object. The ultrasonic has 4 pins. First pin is the trigger, the second VCC, ground, and the echo. The VCC should be connected to the Arduino with a 5 volt, and the ground should be connected on the ground pin on the Arduino. For the trigger pin in our code, we will put first the trigger pin on high state, then we'll have a delay for a 10 microsecond, then we'll return back the trigger state to low. By moving the trigger from high state to low state, a cycle of sonic burst will be sent out, which will travel at the speed of sound and will be received by the echo. After receiving the cycles of sonic burst by the echo will generate an output. The output will be the time in microsecond which sound wave traveled. But the output will be multiplied by 2 because the sound wave is moving back and forth, bouncing forward and bouncing back. So, as a result, in order to get the distance in centimeter, we need to multiply the received travel time value from the echo pin by 0.034 and divide it by 2.
Okay, so my contribution to the project is two things. Firstly, I did the wiring of the car, which is wiring of the components and some of the physical car parts, and connecting the appropriate input and output wires to the Arduino board. And secondly, I was responsible for integrating my teammates' codes together to be put in a single file to be run by the Arduino board. Firstly, I will talk about the wiring. The wiring is simply just a connection of any input or output wires from the board to its corresponding circuit, like for example from the board to the H-bridge circuit. The interconnection within each circuit itself, however, was of course with contribution of the teammate responsible for that part, because they are the ones who understand it the most and they are the ones coding it. Like for example the connection from the power supply to the H-bridge, to the motors, and so on. As for the coding part, I was simply responsible of managing which pins map to which part of the code or which component. One example of that in our code is the 4 pins that control the direction of the motor and whether or not the motor should be spinning. Those were set to the same variables that were used in my teammates' code in their part. So the pins map to those variables. The pins on the actual physical connection map to those variables. This same mapping is done throughout the whole codes, from variables used in the code to actual pins on the Arduino board. And also any analog signals or any analog outputs were managed as an analog output port in the code. One example of this in our code, in one of my teammates' codes, is the speed of the car, as it was an analog value and it was output on an analog port in the Arduino board. That was also handled as part of the integration to selecting which port was the analog port and so on.
Hello, my name is Omar Ahmed. I was mainly responsible for the H-bridge part. The H-bridge is simply a component that controls the movement, the direction, and the speed of the car. It does that by controlling the amount of voltage going into each motor and the direction of the rotation of each motor. It also controls which motor rotates and which one doesn't. We use that to rotate our car because our car is a two-wheel motor, so the H-bridge helps us make one motor stop and the other one rotate so the car can rotate around its axis. The H-bridge takes as input 12 volts from the batteries and it supplies 5 volts to the motors. There are 4 in-pins in the H-bridge which help us control the movement of the motors by setting them to either low or high. There are 2 more pins that control the interrupt, 1 pin for the ground and 1 pin for the input voltage. We set the 4 in-pins as output because they take input from the Arduino and they are initially always set to low. Now, according to the input coming from the accelerometer, we change the values of the 4 in-pins to move the car in a direction. If it's moving forward, the values of the 4 pins are high, low, low, high. If it's moving backward, it's low, high, high, low. It's moving to the right, so we're only controlling one motor, so it's high, low, low, low. And if it's moving to the other side, so it's low, 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 high.